Today's video is going to be basically on pH and pOH, just calculations, okay, or finding concentration of H plus ions or H negative ions. Your blue sheet does have a big acid-base section that's got these equations on there. So knowing how to use those is pretty important. You'll use these a lot. So here's kind of the equations you will use, at least two of them. There's a couple more. pH, so pH is power of the hydrogen ion, or hydronium ions. Remember, H3O plus, same thing as H plus. Those are the same things. And pH, to get the pH, you take negative log of the molarity of H plus ions. pOH is negative log of the molarity of the OH negative ions. All right. If you know the pH scale, it goes from 0 to 14. Actually, you can have a negative pH, and you can have a pH greater than 14 as well. So very, very low is acidic, very high is basic. Right in the middle of 7 is neutral. Okay, 7 is neutral. Other things. Another equation you need to know. Concentration of H plus ions in a solution times the molarity of OH negative ions. So H plus molarity times OH negative molarity is 1 times 10 to the negative 14th power. If you remember from the previous video in water, this is 1 times 10 to the negative 7th. That's 1 times 10 to the negative 7th. Gives you that. And last thing you need to know is that pH plus pOH equals 14. The pH plus the pOH is 14. All right. So let's go down and do little problems. I'm going to get rid of those equations when I do this, but finding some pH and some pOH. Now let's talk a little about logs real quick, okay? Let's talk a little bit about logs briefly here. Not that you need to know a lot about them. You can generally just type them in your calculator. You're going to have to know how to do some of them, though, at least have some idea of them. So if we say pH equals the negative log of the concentration of H plus ions. Well, in water, the concentration of H plus ions is 1 times 10 to the negative 7th. So the pH of water is the negative log of 1 times 10 to the negative 7th. Well, the negative log of that is 7. Negative log of that number is 7. So that's the pH. If the concentration of H plus ions was negative H, that is a smaller amount. That means our pH is now 8. Negative log of that number is 8. Okay, so there is some estimating you have to be able to do. Okay, there's some estimating you got to be able to do on that as we go through things. If the other thing we know is concentration of H plus ions times concentration of H negative ions equals 1 times 10 to the negative 14th. Well, let's say this concentration is 1 times 10 to the negative 5th molar. That means this concentration is 1 times 10 to the negative 9th molar. This is a bigger concentration than that. You know, pH is negative log of this, which would be a 5. This would be a pH of 5 for this solution. It'd be a pOH. pOH is negative log of the concentration H negative, which would be a 9. pH plus pOH adds up to 14. Okay, so this would be an acidic solution. There's more of these than there are of those. And every number increases 10 times more. From 5, every number increases 10 times more. So 10 times more acidic. So if you have something that's a pH of 2 and something else that is a pH of 4, this is not twice as acidic as that. Okay. It means that every number increases 10 times more. So from 2 to 3, that's 10 times more hydrogen ions there, and this is 10 times more hydrogen ions here. So from 4 to 2, that is 100 times more hydrogen ions. It's a logarithmic scale as we're doing things. So you kind of see a little bit you're going through. All right. First thing, what is the pH of an acid that has a concentration H plus of 3 times 10 to the negative second? One thing you do have to be able to do is estimate a little bit. Okay, estimate a little bit. So I know that when this concentration is 1 times 10 to the negative second molar, I know that is a pH of 2. The negative log of that amount is 2. Well, 3 is a higher concentration than that. Higher concentration than that, 3 times more. So our pH should be lower than 2. Should be more acidic. So you do have to kind of be able to estimate that. Now I know that it's not going to be a pH of 1 because that would have to be 10 to the negative 1 power to be in there. So if I want to get this pH equals negative log concentration of H plus ions. Again, that is a molarity. So we do negative log of that number. You just type it in. You do have to put a negative sign in front of it, and you end up with a pH of 1.5. So pretty acidic. That means the pOH 14 minus that would be 12.5. Don't deal with pOH very often. But remember, they add up to 14. Remember also, if I know concentration H plus, I can get concentration OH negative from there. All right. What is the pH of base? That's concentration OH negative of that. So if I was doing this, there's a couple ways I could do it. Okay. I could use this equation, concentration H plus times concentration OH negative equals 1 times 10 to the negative 14th. I could plug this in right there and solve for H plus, and then do the negative log of that to get pH. Or I can find the pOH of this. So pOH equals negative log of the concentration of OH negative, which is 0.004 in this case. So I can plug that in there for concentration OH negative, which gives me the pOH. That is a pOH of 2.4. pH plus pOH always add up to 14. So pH equals 14 minus 2.4 would be 11.6. 11.6, which makes sense. That's a pretty high concentration. If this is 4 times 10 to the negative third, that's going to be something times about 10 to the negative 10th or 11th out here, which gives us that pH. All right. Couple more here. Just got to get used to using these equations some. What's concentration H plus? We want the molarity of that and the molarity of that of beer if its pH is 4.7. pH 4.7. So now it's giving us a pH. So if we think about our pH equals negative log of the concentration of H plus ions, put our 4.7 out here, equals negative log of the concentration H plus ions. So if I want to get an answer to this, I've got to do second function log of a negative 4.7. So move my negative sign over. Second function log, which is 10 to the negative 4.7 power. So I got to do 10 to the negative 4.7 equals my concentration of H plus. So second function that to get there, which is about 2 times 10 to the negative fifth. Which makes sense. You know, if it was 1 times 10 to the negative fifth, that'd be a pH of 5. We're at 4.7, so it's going to be a little bit more concentrated. It also wants concentration OH negative. So to do that, the concentration OH negative, I can do concentration of H plus times concentration of OH negative equals 1 times 10 to the negative 14th. Plug that in right there. So 2 times 10 to the negative fifth is my concentration H plus. Trying to get OH negative concentration. 1 times 10 to the negative 14th. So I'm divide that over to the other side. 1 times 10 to the negative 14th divided by 2 times 10 to the negative fifth. And that's 5 times 10 to the negative 10th. Remember, that is a molarity. That's our molarity. So there's our molarity of H plus. There's our molarity of OH negative. It is acidic, so this molarity should be higher than that molarity. All right. Figure out the H plus concentration, OH negative concentration, pH of a 0.15 molar solution of HNO3. I can only ask you this if it's a strong acid or strong base. So this is a strong acid, so I know it completely dissociates. If it was a weak acid, only a percentage of this would dissociate and you wouldn't get as many H plus ions. So I can ask you this for a strong acid or strong base. Otherwise, you'll need a Ka or Kb value eventually. So this completely dissociates into H plus ions and NO3 negative ions. So that means the concentration of H plus ions is 0.15 molar. So if I want to get, so that is my concentration H plus, that's that answer. If I want to get my pH would equal negative log of that concentration, negative log of 0.15. And negative log of 0.15 is 0.82, I believe. Pretty low pH, because that's a pretty high concentration of H plus ions. All right. And then concentration of OH negative ions, a couple ways you could do it. You can get POH and go from there. You can do concentration of H plus times concentration of OH negative equals 1 times 10 to the 14th. I'm just going to tell you what the answer is. The answer there is 6.7 times 10 to the 14th. Molar is your OH negative. Last one here, you have a strong base, which completely dissociates. So that means the concentration of OH negative is 0.25 molar. So if I want to get POH, I would do negative log of the concentration of OH negative, negative log of 0.25. Would give me the POH. And that is a 0.6 for POH. If I want to do pH plus POH equals 14. I know my POH is 0.6. That means my pH is 13.4. So these equations may seem a little weird at first, but you'll figure them out. You'll also start figuring out some pHs can be in the negative values, but that's kind of weird, and we'll get into those. So just using those equations. See ya.